Hello everyone, my name is Łukasz Majnowski, the Internet of Things advisor and trainer. And today we're going to talk about the AWS IoT Edge device service and the value proposition it offers. But before we begin, please say hi in chat so I know that at least one person is listening, and then I will start the timer and we can dive into AWS IoT device service and how it works. Okay, so let's wait for that first command, and then we are going to proceed, because it's always good to have confirmation that at least one person is listening to what I want to say and what I want to share with you, because this session will provide you the business overview of this AWS service. I will show some technical content as well, but mainly to provide the awareness. Okay, hello Victor, thank you very much for joining. In that case, we are ready to start. Before we go into the service itself, let's have a very high-level overview of typical Internet of Things deployment. We've got local devices and some kind of backend, typically a cloud backend. In our case, that is the AWS Cloud backend. And we've got devices. The AWS IoT Greengrass can be installed on any device like Raspberry Pi or something similar, up to the commercial grade servers. And that gives us the great flexibility, because we can use it on routers, we can use it on smart cameras, and even on those commercial grade servers. And to be honest, based on my experience, we often use those servers, even if we don't really think about them in like the IoT devices. When we install our solution into a factory to monitor the whole production line or some medical facility, in all of those cases, we need to have significant processing power, and that's why we deploy the AWS IoT Greengrass on those servers. And if we speak about the cloud, of course, the cloud is a bunch of servers hidden somewhere, and we do not have access to those servers directly, but we can access the services they offer. And in our case, those servers offer the AWS IoT Greengrass service. According to the AWS documentation, this is the service that is both the edge runtime and cloud-hosted service, which for me personally was very hard to understand, because based on my experience and based on my intuition, something is either the edge runtime or the cloud service. It cannot be both. And at the end of the day, the Greengrass is not both. It is more like a framework, and the edge runtime is just one piece of that framework. Okay, so Mohammed, about your question, how to connect existing PLCs to the cloud. Well, Greengrass can do just that. If you install Greengrass on some edge gateway inside the factory, then that edge gateway can access PLCs using the internal network and can send data to AWS Cloud using MQTT or some other protocol. So the Greengrass service is definitely the way to go if you want to connect your PLCs to AWS backend. Okay, so let's go back to the main topic, but please ask any questions as we go, because we've got 12 minutes left, and that is the hard stop. Regarding the benefits, Greengrass offers, or in general, the edge processing offers cost reduction benefit, and I will show you a number of ways how we can achieve that. It offers the network outage resiliency. So basically, if something goes wrong and our site is offline, let's say the whole factory is offline because of some random external issue, we do not want to have the outage in terms of the production line. The production line should keep working, and Greengrass can make that happen. Finally, we want to have the business platform that can be easily customized and extended by the business users that don't really care about all the technology under the hood. And we can build this type of framework using Greengrass as well. Going a bit more into details, as I told you, Greengrass is Azure runtime. This is just the Java application, and the AWS backend of Greengrass service is rather complex, I would say, because in order to provide that great flexibility from the end user perspective, we need to make pretty advanced setup on the AWS backend, and we will go that way in a second. But let's start with some tangible example. Let's say that we've got a car and we want to access local subsystems of that car, and we want to be able to fine-tune operations of that car to update some settings in the real time. What we can do is we can install the AWS IoT Greengrass directly on a device that we install in the car itself. And that brings lots of benefits. First of all, since this device is already installed inside the car, it can access any subsystem of that car using local interfaces. So there is no need to expose any internal endpoints to the outside world, because Greengrass is already sitting inside the car, like physically. That adds the security, and it adds also the real-time capabilities. And as you can see on the diagram, we've got the Greengrass and we've got the ingest application, and applications are called components in the Greengrass nomenclature. So this ingest application can access whatever endpoints of our car using local protocols and read data. Once we've got the data, we want to act on it. And we can act on it, for instance, using some kind of machine learning inference at the edge, hosted as additional Greengrass application component. And that gives us two major benefits. First of all, since we are using our own hardware installed inside the car, we do not pay for any cloud infrastructure, because we can do all the inference using this device. So we do not pay for cloud resources. Secondly, if this car travels some far away outside of the network coverage, our solution will still operate, right, without any issues, because this machine learning inference happens on a device itself inside the car, and it does not require constant access to AWS backend in order to operate. So that brings that gives this network resiliency. And of course, since everything sits inside the car using the local network, we've got real-time loopback. So if something is off with the readings of the subsystems, our machine learning model can fine-tune everything in the real time. But of course, we do not want to only have like static deployment. We want to be able to constantly improve the end user experience, to add some new features to our product or service. And we can do so by uploading telemetry data from our devices, in this case from car, to the cloud backend. So we've got the upload application, right? And as you can see, once again, this application sits in this device, is using some kind of local storage. So in case of lack of the network access, we will simply store data to the local storage, and once this car is back online, this application can read data from local storage and send it to the AWS backend. And it can do it in a smart way. So first of all, we can reduce costs by sending only values that have changed since the last communication to AWS Cloud. We can add some compression, so we are going to reduce the network bandwidth consumed by our device, and we can do even more advanced things, like, for instance, remove some personal data that should not leave the car physically, right? So this upload application can got that logic embedded as well. And once we send our data to the AWS Cloud, we can transfer it in a number of ways using MQTT, like a default mechanism, but this is often not the most cost-effective way to send telemetry data from our devices to the backend. And using AWS Greengrass capabilities, we can send data in using other methods. You can store the data directly into the time series database, or we can store it even in the private S3 bucket. So it really depends on how you want to work with the data you obtain from your device. And for that specific use case, you can find the cost-effective way to both transfer and store your data. But let's move to the business platform, because business users don't really care about all that. They care about the business applications. So as I mentioned previously, applications hosted on the Greengrass are called components, and we've got three types of components. We've got AWS provided components that offer basic functionality almost out of the box. We've got public components that you can access on the public internet and install on your specific device. And you can create your own private components that you don't want to share with anyone. And based on my experience, my customers typically use AWS provided components for the basic functionalities, and private components to implement and execute some kind of logic that is very specific to their use case, and they don't want to share it with the external world. In terms of the frameworks, you can use whatever programming language you wish to write your application, like Java or Python, as long as the device that hosts Greengrass got a specific runtime and dependencies to run that specific application. So you need to prepare your device, and once the device can support it, Greengrass does not really care about the language, about the binary. You can use whatever meets your purpose. Even more, you can use Docker, and that is really interesting concept, because you can Dockerize your applications using Docker containers, and Greengrass will basically orchestrate all of those containers for you. So it will check if those containers are healthy. If they are not healthy, it can try to restart them, can restore the operationals of your applications hosted as Docker containers. So this is very nice approach, because this way you don't really care about dependencies on the operating system level. You just install Greengrass, and business applications are deployed as Docker containers. Speaking about deployment and business users, let's say that we've got the data scientists that created some new video recognition application, right? And they want to deploy that application on a fleet of Greengrass devices installed in a fleet of our cars, right? So they can do that remotely using the AWS IoT Greengrass deployments. And the same goes with DevOps consultants. Let's say that they created some new configuration to fine-tune either the Greengrass running in our car, or maybe in the smart camera. Because as I told you, Greengrass can be installed on number of different types of hardware. So those people do not really have to care about all the technical details, right? So what's going on under the hood, right? They can develop and test locally their solutions and deploy them remotely to the huge fleet of devices using Greengrass deployments. And it will work without them really going into details. But there is always the trade-off, and with great flexibility comes great complexity. This is how the Greengrass service looks from the cloud perspective. And as you can see, it is pretty complex. There are a number of different things that you need to set up on the AWS side to make the whole system work for you, starting from various endpoints, credentials. You need to configure a number of different AWS services to make this whole framework work. So I won't go into that because the concept itself of the AWS configuration would take way more than 50 minutes to explain. So let me stop here and ask if you've got any questions for the last minute that we've got. And yeah, that's all what I prepared for today. Okay, I don't see any questions. So going back to the Mohammed's question, even though I used car as an example, the industrial Internet of Things implementation of Greengrass on inside some kind of factory or research facility can use Greengrass for sure to access PLCs in a secure way and without exposing those PLCs to the external world. Okay, so in that case, thank you, Victor. Thank you, Mohammed. Thank you, everyone, for joining. I hope that was interesting for you, and I will speak to you next time. Łukasz Malinowski. Bye bye.